Thank you all for coming. It's my pleasure to introduce Liz Arnold from Montana State University on four big ideas of mathematical modeling.
Thank you, Gavin, and welcome everyone and happy Valentine's Day. I'm going to talk about four big ideas of mathematical modeling, and I am currently at Montana State University in the Department of Mathematics. And so before I begin, I want to kind of acknowledge that this work that I'm going to talk about is really a collaboration among some amazing colleagues of mine all at Montana State. So Beth Burrows, Mary Alice Carlson, Elizabeth Fulton, and Megan Wickstrom. And the work that I'm going to present today is part of two NCTM books that we have wrote called Becoming a Teacher of Mathematical Modeling. And while those books focus on K-12, all of the work that is presented in this book is part of a decades-long kind of research and focus on mathematical modeling in K-12, undergraduate, and graduate school. So on behalf of myself and all the team, we're going to talk about the four big ideas of modeling that are presented in these books. So just to kind of begin an overview of like our perspective of what mathematical modeling is, mathematical models are representations of the world that we use to understand phenomenon and make decisions. And the modelers are those that are creating those representations. And that modeling is the process of creating those representations. And so when I think about modeling as a process, if you're familiar with any of the modeling literature, you will probably likely come across one of these images. And so they're describing modeling kind of as a cyclic process that you go through these kind of steps and components. And we agree, like we love these images. But something that we have found in the teaching of mathematical modeling is that if we focus too much on these processes and these cycles, either us or our students tend to view modeling as this like step-by-step procedure of like, I need to get through this problem, this part. I can't get to this part before I do this part. And I think as we all know, modeling is super messy and there's not one way to do modeling, and we can come at modeling in all different directions and flows, and we use our different perspectives. And so to kind of help us conceptualize mathematical modeling, rather than focusing on this process and perhaps like this maybe step-by-step procedure, this was like motivation for us to develop these four big fundamental ideas about mathematical modeling. And we use these four big ideas to ground ourselves in the process of mathematical modeling. So the four big ideas are that modeling begins and ends outside the mathematical world. Modeling deals with situations that are open and complex. Modelers exercise judgment when investigating problems, and modelers decide when a solution is good enough. So again, we developed these four big ideas based on years of working with teachers and working with modeling in the classroom. And so in the next few slides, I'm going to talk about what each of these big ideas are, and then I'm going to highlight them through an example. All right. So big idea number one is that modeling begins and ends outside the mathematical world. And so in this figure, you'll see this cloud that kind of represents an authentic problem or situation that is something that is of interest to our students that are doing the modeling. And then in this hexagon, you see this mathematical world. And so modeling kind of goes back and forth between the cloud and the hexagon. And they are all problems that are rooted in some authentic daily experience that is a felt need of our students or of those that are doing the modeling. And so we really want these modeling problems to be authentic from like the learner's perspective. So what matters to them and why? And we also want these modeling problems to be something that we can use mathematics or statistics to answer and make decisions about. And it's really great if these modeling problems can make a difference to the students and their communities. So modeling, big idea number two is that modeling deals with situations that are open and complex. And so modeling problems really grow out of these authentic experiences. And as we know, the real world is messy and complex. And so these authentic experiences are really often ill-defined. And there's not very clear boundaries. There's not a single correct path. There's not one approach that works for everything. And what I I kind of have a love-hate situation with this big idea because I love messy problems, but I also work really hard as a teacher to make my problems very clean and not ambiguous for my students. I want it to be very, very clear. And so it's very challenging for me when I teach modeling to kind of remove myself from that stance of like, I don't need to make these problems very clear. Modeling is messy, complex, and they have problems that are ill-defined. And it's our students or the modeler's job to take these messy and complex and open situations and to remove some of the complexity and make it manageable to solve. And then when we move from these situations that are very complex and the decisions we make them less complex, that really stems from us, the modelers, making choices. What are those choices that we make? Well, it really depends on what we as modelers value. And this leads to big idea number 3, which is that modelers exercise judgment when investigating problems. And so in any model that we do, there are a lot of choices that we have to make. There's a lot of assumptions that we make. And these choices really depend on what we value. But it's also very important that these choices depend on what others value. And so bringing in these multiple perspectives and really seeing the situation from others' perspectives is a big component of Big Idea 3. And so when students engage in Big Idea 3, they're acknowledging what they value and what others value and how they're going to bring that to the situation being modeled. Okay. Big idea 4 is that modelers decide when a solution is good enough. And this is really challenging for students because I feel like if I think about students going through K-12, how do you know when you're correct with a math problem? Well, you ask your teacher or you look in the back of the book and see if your answer matches it. And in modeling, because there's not one way to approach a problem, there's not one correct solution. And so who tells you that your model is done and correct? Well, the modeler does. And so Big Idea 4 really stems on it's the modelers deciding when their solution is good enough. And as teachers of modeling, to help our students kind of answer that question is you can ask the students, well, is your solution useful? What perspectives and which perspectives does your model consider? And what do you notice about the different solutions that your students are all bringing with these different perspectives? And so these are really challenging but very empowering questions that we can ask our students, the modelers, when they're engaging in the modeling process. So by attending to these 4 big ideas, we argue that teachers can keep the focus on modeling. And so what I'm going to do next is go through an example of modeling the concentration of a toxin in a circulatory system. And I'm going to kind of highlight how this problem addresses each of those 4 big ideas. Oh, okay. So I felt this was a very relatable kind of context, dogs and chocolate. And so if you would like, feel free to write in the chat, what comes to mind when you think about dogs and chocolate? And this was a very timely thing because this happened just the other day. I had this box of chocolate that my husband bought, and we went and did something, and we came back and it was on the floor. And both our dogs were looking at us. And so my first thought was like, oh no. So I picked up all the chocolate to see if I could figure out which ones they ate. And then my second thought was like, well, which dog ate the chocolate? Because as you can see, these 2 dogs differ in size. And so I might be a little bit more concerned if one dog ate the chocolate over the other. And so this is an authentic experience. This is an authentic problem. When my dog eats chocolate, I think, oh no, what do I need to do? And so this example is something that we've seen in the classroom, and a teacher had this experience, and the teacher that I'm going to talk about, Ruby, used this context to build a modeling problem and a modeling lesson in her classroom. So Ruby is teaching pre-calculus, and she's about to focus on exponential functions and half-life equations and like exponential decay. And in her class, she has a photo of her dogs because she loves her dogs. And so it's this classroom community feature that her and her students often talk about their animals. And so she realizes that this is an authentic problem that will mean something to her students. And this was also a personal experience for Ruby and like myself is she had a scare when her dog ate some chocolate, and she had this idea that her question of like, what do I do, can be turned into a modeling problem that she can give to her students. So here's the problem that Ruby posed to her students. Dewey ate some chocolate, and Dewey is the name of her dog. What should I do? And how do I know if this situation is dangerous to my dog's health? And so our students were really excited to kind of get going with this modeling problem. So I'm going to go through and share how each of the big ideas relates to this dog and chocolate problem. And so big idea one, as a reminder, modeling begins and ends outside the mathematical world. And so Ruby is choosing an authentic experience to her, and it's something that will be meaningful to her own students because most of them had dogs. And it's one that can be investigated with mathematics or statistics. And so you can see the math problem that is posed is how long until the danger has passed. And so Ruby's really thinking about like, well, how long do I need to wait in order to decide whether or not I need to take Dewey to the vet? And what she found is that her students can use their mathematical knowledge about exponential functions and graphing, and they can use that knowledge to predict the amount of theobromine in the dog's circulatory system for a given time. And theobromine is the substance in chocolate that's really dangerous to dogs. And so again, Ruby is attending to big idea one by using an authentic experience that her students can use the mathematical toolkit that they have, exponential equations, to give her an answer. Big idea number two, again, is that situations are open and complex. And so I'm going to pause for a minute and give you time to maybe put some thoughts in the chat. What would you do in this situation? When would you decide, if you have dogs, when would you decide to take them to the emergency vet if they ate some chocolate? And so feel free to share your thoughts in the chat. Um, what I find interesting is that if you just do any Google search, as one does when your dog eats chocolate, you come across these images that say they talk about the toxicity level in the chocolate, they talk about the amount. You can see in one of these pictures, there's about the size of the dog that matters. So there's all these different kind of ideas that come into play when you question, oh no, what do I do when my dog ate chocolate? Do I need to take them to the vet or not? And so this, I feel like, really encompasses this like open and complex big idea in modeling. And when I think about this problem as the teachers, as Ruby did, so here's Ruby's thought process of like where this problem could go. Where could this modeling problem take off? What could my students do? And you'll see it's very open and complex. We could think about when we take the dog to the vet, we could think about, well, how much theobromine is actually dangerous for dogs. We could think about when is the dog in the clear. And with all of these like mathematical questions, there's other decisions and assumptions and research that we need to do. So, well, there's different types of chocolate. I need to research all of these all of these different types of chocolate. And so what this figure is just really illustrating again is modeling problems are open and complex, and there's a lot of different ways that we can approach the problem. And so now what I want to do is kind of share what the students thought about this problem and how they attended to Big Idea. And so they brought in a lot of different perspectives. And so some of their initial brainstorming ideas were, well, the breed of the dog matters and the size of the dog matters. And so the smaller pug that you saw in my picture, if he ate the same amount of chocolate as the golden retriever, I'd be a little bit more concerned about the pug versus the golden retriever just based on size. But then they also talked about like, well, we need to think about whether or not the dog has an empty stomach because that might matter according to whether or not they ate chocolate. And then another thing that the students really talked about was the type and amount of chocolate because that's really important. And so with some research, they found that dark chocolate is more dangerous to dogs than the lighter milk chocolate. And so what the students decided to do, again, they used their mathematical toolkit, which involved exponential functions, is that they wanted to represent how much theobromine was in the dog's system over time. And what they really focused on instead of the amount was kind of the concentration of theobromine. And so again, this really illustrates that modeling is open and complex, and there's a lot of different ways that we can approach a modeling problem. And there's not one right answer. All of them are great, and you're just bringing different perspectives to it. So big idea 3 is that modelers exercise judgment. And so Ruby ensures that her students view these models as a way to make a consequential decision. And the consequential decision is whether or not I need to take my dog to the vet. And there's a lot of factors that go into it. Going to the vet is really expensive. And so you kind of have to weigh the risk to the amount that it might cost. And so their answer, if it's just like, yes, take your dog to the vet if he eats any kind of chocolate, might be consequential if you don't have the funds and the resources to take your dog to the vet. And so if the students decide, well, you could wait, I don't know, 15 minutes or an hour. Again, these are all decisions that have a consequential decision for when should I take my dog, if at all, to the vet. And so in exercising judgment, again, the students decide to use their mathematical toolkit of exponential functions, and they're really focusing on time and the amount of theobromine, the toxin, in a dog's system. And they understand that the answer to their model will give an answer to Ruby's question of when do I take my dog to the vet? And then the last big idea is modelers decide when a solution is good enough. And so Ruby ensures that students are, they're being the ones that are the decision makers of whether or not their solution and their model is good enough. And she can pose some questions for them to consider. And so she also, as a teacher, when you're asking your students, is your model good enough, is have them be very explicit about the assumptions they are making in their model and what are some of the limitations in this. And so, for instance, in this particular problem, if the students are only looking at the size of the dog and not the chocolate, there's consequences to it. And so as a modeler, we want our students to look at the decisions they're making, why they're making them, and then the limitations of those. And what was really fun with this modeling project is that one of the students actually worked in a vet's office. And so what Ruby did is she had her student bring in the vet's table of how much chocolate is bad for dogs, and they compared the results from their model to the vet's chart. And within that, if they found discrepancies, what that allowed them to do is go kind of back to the beginning or at some part and start revising their model so that they can get a little bit closer to the predictions that are made by the vet's office. So in a nutshell, Ruby ensured that the focus remained on modeling by focusing on these 4 big ideas as the foundation of mathematical modeling. And so the last thing I kind of wanted to talk about is that through all of our work with mathematical modeling is we've really found that empathy can be fostered through mathematical modeling. And so empathy is the ability to understand and be sensitive to another person's perspective. And by thinking about modeling and these big ideas, they really bring up this idea of multiple perspectives and thinking about different approaches. So we have found over the years that mathematical modeling really broadens students' understanding of what mathematics is, whom it is for, and how it is applied to the world. And it really empowers students to use their mathematical knowledge and to use their own mathematical knowledge. They don't need to wait until they know all of these complex mathematical toolkits. They can use the math they know to solve a problem about an authentic situation, and that their answer has consequences and it's meaningful. And what I really appreciate about mathematical modeling is it really helps students look at different perspectives. And when they look at different perspectives, they're starting to develop some empathetic critical thinking skills, which I think is very powerful for our students. So some things that we can do as teachers when we're teaching mathematical modeling in any situation, so this can happen at any time in the modeling process, is to ask your students, well, what makes this situation important? And who is this important to and why? Who else might care about it? And what perspectives will they bring into this? Or what perspective should we consider when thinking about this problem? And then it's also very powerful to ask students, well, what questions do you have about the situation? And when they start to ask questions that they have about the situation, it gives you, the teacher, the opportunity to think about, like, who might I bring in that could give them some of those answers? And so in this Ruby dog and chocolate problem, the teacher might be able to get a vet and have the vet come into the classroom, and the vet can share their perspective about dogs and chocolate. That will give the modelers and the students new insight into the problem. And so just to close, I kind of want to read this quote that this is our view about the intersection of modeling and empathy, that modeling provides a way for issues to be understood beyond right or wrong, and beyond even agree to disagree. Modeling provides a way for students to use their mathematical skills to examine different solutions to authentic problems based on different perspectives. And that students who understand that two different models of the same situation can capture different perspectives have learned empathetic critical thinking skills, which I think is really powerful and something that I want my students, when they're modeling, whether they're in kindergarten or grad class, I would love for them to take away some empathetic critical thinking skills. And so with that, I thank you all for attending and listening and kind of going through a speed talk of ideas that we have in the book. So I'm happy to answer any questions that you all have. Thank you.
Well, Liz, thank you so much. It was a pleasure having you.